In question number 5a, it says verify the equation secant x over tan x plus cotan x equals sine x is true. Now we plug in 30 degrees. If we do that, we get the left side of the equation is 0.5 and the right side is equal to 0.5. And we also plug in pi over 4 and we get 0.707 and 0.707. Now this indicates that this is true for those two values, which gives us the thought that probably this is likely an identity, but we don't know for sure. We can only tell if it's an identity once we prove it. We can actually prove this fairly easily. We can rewrite this as 1 over cosine x, and this becomes sine x over cos x plus cos x over sine x. And what I'm going to do is I'm just going to get rid of all the denominators here. I'm just going to multiply the top by cos x sine x, and we're going to multiply the bottom here by cos x sine x, and we're going to check to see if that ends up equaling the sine x on this side. Okay, so when we multiply that through, I end up, the cos's cancel out, so in the numerator I end up with sine x. Here the sine x cancels out, sorry, the cos x cancels out, so I end up with sine squared x plus, here the sine x's cancel out here and here, so we're left with cos squared x. And then this is an identity, and that cos squared plus sine squared is equal to 1, so we end up with the left side is sine x, and the right hand side is also sine x that we can bring down to here. So this is in fact an identity because for all values of x, this is actually true. Part B of this problem says, what are the non-permissible values of the equation in the domain? So it says from 0 to 360, but I'm going to change this because we really should be working with radians. So we're going to change that to 2 pi. And so the non-permissible values are wherever we're dividing by 0. Okay, so this means that secant can be is when cosine is 0, they were dividing by 0, so we're going to say cos x cannot be equal to 0, and that means that if I take a look at where cosine is equal to 0, it's equal to 0 when the horizontal position is equal to 0, so pi over 2 and 3 pi over 2. In degrees, that's going to be 90 degrees and 270 degrees. So that's our restriction from the cosine. Okay, we actually have the cosine here as well. So there's our cosine x is equal to 0. We cannot have sine x equal to 0 because here we're dividing by sine. So we cannot have sine x equal to 0 as well. And also tan x, we'll do this in a second, but tan x cannot equal cotan x. Okay, so we're going to do sine x first. So the restriction then is sine x cannot be equal to 0. Okay, if we take a look at where sine is equal to 0, sine is equal to 0 in the vertical position here and here. So x cannot equal to 0 and pi or 0 and 180 degrees. Okay, so it's not equal to. And then lastly, we have to just make sure that tan x is not equal to cotan x. Okay, so this is from this denominator. We can't let this denominator equal to 0 as well. So when I solve this, tan x not equal to 1 over tan x. So I end up with tan squared x is equal to 1 plus, so we're going to end up with tan x plus minus 1. So where tan is plus minus 1, I'm just going to draw a different picture for this. We know that this is not possible either. So in those two positions, we're going to have a solution. Now we have to be careful because one has to be positive and one has to be negative. And that's not possible here because tan, if we check our answer here, when tan is equal to 1, cotan is equal to 1 as well. And here, if tan is equal to 1, cotan is equal, negative 1, cotan is equal to negative 1 as well. And here, tan is equal to 1, cotan is equal to negative 1, and vice versa. So I actually made a mistake here because this should have been negative like this. So negative tan squared is equal to negative 1. And we should have actually concluded that from that tan squared is not equal to negative 1. So that never happens. Tan squared cannot be equal to negative 1. So there's no restrictions for this denominator here. So then the only restrictions are going to be in terms of the sine x and cos x equaling 0. So these solutions and these solutions are our non-permissible values.